We strongly suggest you try a practice test before you take the official test. Could be one that you made or this one. And the protocol in general would be to look at the example, read it carefully, write it down, give it your best shot, and then play the video to watch the protocol to see if you've got the correct answer. All right, so let's get started. Our first one, and we'll write it big here, x squared minus 3x minus 28, and we were asked to factor it. So again, you look, is it in standard form? Yes. Is there any common factor in each term? No. So then put two sets of parentheses as you try to brainstorm what could be the factors of this trinomial. Well, we know our first term, the only possibility is an x there and an x there. And now we're looking for factors of 28 that have a difference of 3. So again, you can write them out, but for this, we're assuming you would say 7 times 4. 7 times 4 is 28, and the difference between them is 3. But to get a negative sign in the middle, your 7, the outers, would have to be negative and your inners positive. So when you checked it by the FOIL, it checks out. And let's take a look. And let's get our answers back here. All right, now you could have the x minus 7 first and then this, but this is perfectly acceptable. All right, let's go on. So here the instructions completely factor by grouping. So let's rewrite it so we can see it big. AZ minus 2BZ plus 2AX minus 4BX. Now, sometimes we have to rearrange the terms, so we have to inspect it a little bit. So let's go to the whiteboard. Now I see a z there and a z in this term, so that looks good. And an x and an x in this term. Okay, and I could see what I could factor out now from the first two terms. Well, it looks like a z. And then I'm left with an a minus 2b here. Now, what can I factor out of the next two terms? Well, we said there was a common x here, and there's also a common 2. So plus 2x, and now I'm left with an a minus 2b. So now I have two terms, and there is a common binomial factor in each of these terms. So I could take out that factor, a minus 2b, and then I pick up on these other two, the z plus 2x. Keeping in mind that sometimes you have to take out a negative value to get your signs correct. All right, let's go back. And again, they have it switched around, but this is perfectly acceptable. All right, let's go on. In this example, we're going to be working with radicals. Here is our basic formula, and we want to solve for d. And we have for this the square root of 2 times g, and our value for g is 90, plus the square root of 2 times h is 115. So this will then become the square root of 180 plus the square root of 230. Put this in your calculator, and again, you're rounding off to 2 decimal places. So we get this, and looking to our third decimal place, it's a 2, so we just drop it, and there is our answer. In this example, we're asked to look at this quadratic equation and then identify our A, B, and C terms. So A, B, and C, and our A term is going to be a 1. Our B term is a -7, and our C term is a +2. So that's step 1 of this example. Now we're asked to put it in the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac, and this is all over 2a. So let's do the substitution. Now b is a -7, so a negative b makes this a +7. Now we square a -7 and get 49. And then -4. And our A term is 1. And our C term is 2. And that's going to be all over 2 times A. 2 times 1 is 2. So we get 7 plus or minus the square root of 49. Now here this is a -4 times 2 in a sense, will be a -8. And that's all over 2. So this is going to be 7 plus or minus. Now 49 minus 8, the square root of 41, all over 2. Now you can't simplify 41 because there is no perfect square factor, and there's nothing to cancel out. So we're going to get 2 solutions, and you would list them in some cases separately, or you might be able to do it this way. Let's see what they show us here. So we identified the A, B, and C correctly. Let's go on to the next slide where they're asking us how many solutions do we get. And we get 2 different real solutions. Now remember, if under the radical sign you ended up with a negative value, then there would be no real solution. If under the radical sign this became a 0, then you would just have 1 repeated solution. But here we're asked to put in the items separately, so that's what they're doing. Let me clear it up. And you can see 1 would be negative and 1 is positive. Now in this next example, we have a stone is projected vertically upward from a platform. So let's make our little platform here. This is 12 feet high. It's going to be thrown up, and then eventually it's going to fall down. And they're giving us some parameters here, and this is the formula we're going to use. So let's set this up. So negative 16 t squared plus our rate is 102 t, and our initial height we're saying is 12 feet. Now we're asked, how long will it take for our stone to reach its maximum? Well, for this we're going to use the vertex formula, because this is the vertex, and that is negative b over 2a. So now we do some substitution. Our b value is 102, but it's a negative b, so we put in a negative 102 to replace the b. And 2a, a is a negative 16, so 2 times a is a negative 32. So negative divided by a negative will give you a positive here. And when we do the division, we get this. But they're asking us to round to 2 decimal places. So we go to our third decimal place. It's a 7, which will now drop, but change the 8 to a 9, which is what our answer is. Now for step 2 of this, they want to know what is the height. So we now have a value for t, and we do our substitution. So negative 16 times 3.19, we said, squared, plus 102 times 3.19 plus 12. All right, take a moment to put that into your calculator and see what you get. So when I do that, I get 174.5624. We're asked to round to 2 decimal places, so I go to my third decimal place. It's a 2, so I'm going to drop it and leave my answer as this, and that is correct. This is our 6th example, if you're keeping track, and we're asked to completely factor this. So let's write it big here. 3x to the third plus 13x squared plus 42x. Now, is there a common factor? Yes, there's an x that's a common factor. So we then get this. And factor now our trinomial. And we're looking factors of 42 that add up to 13. Well, a 7 and a 6. And our signs will both be plus. And if we FOIL that, we get this. And if we distribute it, we get that. And that looks good. And here we have them lined up just like they did. But again, this second factor could be switched and it would still work. And in example 7 now, as we look at it, let's write it big. Y plus 7, the quantity squared, equals 121. And we're asked to solve that. That is a quadratic equation. And for this, we'll use the square root property, where if we take the square root of this side, plus or minus the square root of that side. Now, again, there's a little 2 there. When you have this kind of arrangement, taking the square root of something, it just becomes the radicand. So we get y plus 7 equals. Now, this is a perfect square, so this will be plus or minus 11. Transpose the 7, and you get y equals a negative 7 plus or minus 11. So we get then y is a negative 7 and a negative 11 is a negative 18. And a negative 7 and a positive 11 is a positive 4. So when you have a binomial that's squared, using that square root property is a good way, and what they're actually looking for in working this example. All right, let's go back, and there are answers, 4 and a negative 11. In example 8, we're asked to find the height of a triangle, and we have the area. So reading it carefully, pause. We want to find the length of the base and the height. A diagram will be useful. So there's a triangle, there's the base, and there's the height. And the formula for a triangle is area equals 1/2 the base times the height. Well, we say the area is this, but if we get rid of the fractions, the formula becomes, again, multiplying both sides by 2 here. We get 2a equals the base times the height. Okay, so 2 times 247, and then we will designate our height as 7 feet greater than the base. So doing some substitution here, 2 times 247 equals our base, and our height we say is the base plus 7. So the protocol would be find this, distribute this, put it in standard form, and then it should factor because the answers are whole numbers. All right, taking a look at this, I multiplied the 2 times 247 and got 494. Distributed this, brought that over to the other side, and I end up with this trinomial equals 0. Now it's a matter of factoring. Well, this is going to be a b and a b. But then what are the factors of 494 that have a difference of 7? Well, I set up my little factoring tree over here. 2 goes into there, and I get my 249 again. And then I have to find factors. This was a challenge. Now, this is not even, so you can't take out 2 out of there. So then I looked and I said, well, I add these together. I get a 6 and a 7. This is 13. So I can't take a 3 out. I can't take a 4, I can't take a 5, a 6. I might try a 7, doesn't go evenly. Then no 8, no 9, no 10. 11 didn't go even, or didn't go. And then I tried 12, that 2 doesn't go. So I tried 13 and it worked out. So it took me a little while, but then what do I get here? Well, 2 times 13 is 26 here, and 19, and there's a difference of 7. So this one was more challenging. So 26 times 19, and we need our inners to be positive, outers to be negative. So when we equate each of these to 0, we get here b is a negative 26. That's not going to work. We can't have negative values. Here b is 19, and that worked. So our base is 19. Add 7 to it, and our height is 27. Again, there's lots of algebra here and skill. Let's go back to our, and there the answers are. The height is 26. Let me clear it up. And the base is 19. So this one was challenging. Now, in this example, they're saying they want you to put this into standard form. So that would be 4a squared, transpose the 25, and now they want you to factor the left side. So, do you recognize anything here? Well, this is a perfect square. This is a perfect square. We have the difference of perfect squares. So this will factor into its conjugates. 2a, 2a, 5 and a 5, and 1 is plus and 1 is minus. And that's what they're looking for here. They've asked you to put it in standard form and then factor it and then show the factors equal to 0. Now, what they're going to ask next is what would be the solutions of this? Well, let's clean this up here. And our protocol is to equate each of the factors to 0. So this is going to be 2a, transpose the 5 to the other side where it becomes a negative 5. Divide both sides by 2. So a equals a negative 5/2. And here we can do this mentally. Transpose that. That becomes a positive 5. So we get a equals 5 divided by 2. So one's a negative value, one's a positive value. And if we look and then clear this up, there are our solutions. Here we're asked to find the greatest common factor. Well, they're even, so you know you can take out a 2. They're also, you could take out a 10. So we think maybe we could take out a 20 out of each, and that would be correct. And then the greatest power of x that you could take out of each one is x to the 3rd. So again, not too bad. Again, you want to take out the greatest common factor. All right, let's go on. Here it says the perimeter of a rectangle is 40 yards. What will the dimensions of the rectangle with a maximum area? So for this, and recalling our lesson, we have to use the perimeter formula. The perimeter is 40 equals 2 lengths plus 2 widths. And then we want to find the maximum area. A equals length times width. So here we said starting off we divide everything by 2. And let me go to the whiteboard. So this is going to be 20 equals L plus W. And we want to solve for one of the letters. So W equals 20 minus L. So we then use our area formula. L times 20 minus L. And that's going to be a negative L squared plus 20L equals 0. So again, we're looking for a vertex, which will be the maximum. So the vertex formula once again, a negative b over 2a. So our a is, well, let's get to b first. Our b is 20, so a negative 20. And our a is 1, so 2 times a negative 1 is a negative 2, gives us a positive 10. So our vertex, the maximum, will be 10. Well, we go back to we didn't make a picture of this, but we said that if one side is 10 and the other side is 10, we don't really have a rectangle here, we have a square. So our dimensions, once we subtracted this 10 from the 20 that we had left there, is 10. So let's take a look at our answer here, and it checks out. So our length is 10, our width is 10. And this was the protocol to get it. Now, generally I found these to be rather easy because they tended to be squares that you work, but this is the protocol to get to the answer. All right, now for item 12 here, if you're keeping track, they want us to multiply the following radicals and then simplify. So the square root of 3 times the square root of 8 is the square root of 18. And that's what they have when you multiplied. Now, to simplify radicals, we're looking for, is there a greatest square root factor of 18? And you brainstorm a little bit, and hopefully you ended up with a 9 times 2. 9 is the greatest square root factor, or perfect square factor, in 18. So the square root of 9 is 3, the square root of 2, and that would be in its simplified form, and there's the protocol to get to it. So hopefully that was something easy. All right, let's move on. Now, a store owner estimates that by charging X dollars for each lamp, he can sell this many lamps. What price will yield the maximum revenue? Now, if you're doing this cold without lessons prior to this would be a challenge, but we know the protocol for this is just to multiply these. And we get then, I'll put this x value first here, negative x squared plus 30. and we know that's going to equal 0. And now we want to find the vertex of this. Negative b over 2a. Well, our b is 30, so a negative b will be a negative 30. Our a is 1, so 2a is 2 times negative 1 is negative 2. So this becomes a positive 15, which is what our answer is. Again, reflecting on the lesson, you've done some certify like this and know the protocol. All right, for number 14, and we're moving right along, one number is 2 more than another. So this will be one number, and the other number is 2 more than that. The difference between their squares is 36. So if we squared that and squared that, we're saying the difference between these is 36. So what would the equation be? Well, I'd put this one first. X plus 2 squared minus, because this would be the larger number, and then this is the smaller number. And we're saying that difference between these two numbers is 36. So let's solve it then. Well, to do so, we have to expand this binomial. I'll write it over here. X squared plus 4x plus 4 minus x squared equals 36. Oh, this is going to be actually a tad easy because our x squares cancel out here, and we get this. So I'm going to transpose the positive 4 becomes a negative 4 here. So this is 32. And then 4x equals 32. X is going to equal 8. So this is 8 here that we're going to square. And this is going to be 10 that we're going to square. And 10 squared is 100. That's this then. And this is minus 64. And that equals 36. So there are our answers. The numbers are 8, and then 8 plus 2 is 10. Now, this person, when they did it, had it incorrect. Somehow they chose these, which wouldn't do that. So 8 and 10. Now, interestingly, a negative 10 and a negative 8 also work. What are the numbers? And we're almost finished. This is number 15. There's 16 questions altogether. Here they're asking us to set up this equation. One number is 40 more than another. So there's this number. And they're saying their product is this. So x plus 40. And the product is a negative 400. So there it is right there. Now they want us to probably solve this too. So let's go to the next screen. Yes. All right, let's solve this. by going to our whiteboard. Erasing this. So this will be x squared plus 40x plus 400 equals 0. Now, I don't know if you notice this, but this is a perfect square trinomial, and 400 is a perfect square, so 20 times 20 is 400, and if we add them up, they add up to a positive 40. So our answer is x equals a negative 20. And I was doing so well here. And a negative 20. When you do a perfect square trinomial, you get two of the same answers. So our answers are going to be x is 20, negative 20. And then if we add 40 to it, we get the other answer, x is positive 20. So these are our two numbers. Going back to our regular, there's a 20, and there's a negative 20. Again, this person had it incorrect there, so they lost points on this. And I think I gave them partial credit because they had one of the answers. Yes, let's clear this up so you can see it. They got some partial credit based on the work. They just messed up on the sign a little bit. But you can't have two numbers being the same if one is 40 more than the other. All right, our last one coming up. Okay, solve the following quadratic equation by factoring. Separate the answers with commas. So let's put it in standard form. 7x squared minus 4x minus 3 equals 0. I had to transpose that. All right. So no common factors. Two sets of parentheses. We know this has to be 7x and an x. Now, the 3 is prime, so the 3 could go there or there. If it goes there, you get a 21. That's not going to work, so it goes here, like so. Now, what will your signs be? We have a negative 4 in the middle, so your outers have to be a negative 7. Your inners, a positive 3. Now we equate each of these to 0 using a shortcut here. So this becomes x equals, transpose that, a negative 3 divided by 7. X equals a positive 1. And let's see, and they have that correct. Okay, well again, this can be watched more than once. You want to have confidence that you can get these answers and show the detailed work to support your answers. And this will wrap this up.